So in this video we will discuss about how to perform a rotation in OpenGL. So basically when we want to perform rotation in OpenGL, we can perform in two different ways. One is called rotation about fixed point and rotation about the origin. So we'll discuss like what it is and how we can write the code for it. So to begin then, actually see, when we say a rotation about fixed point, what happens is, see, if you see, we had an original triangle like this, this triangle. After rotating, what has happened, one of the point of the triangle has remained fixed. So triangle has three vertices, out of which one vertex has remained fixed, the other two has rotated. This is called as rotation about a fixed point. Coming to this picture, we have rotation about origin. So when we saw the rotation about the origin, so we have drawn a triangle and we tried to rotate it. The triangle got rotated, but meanwhile it got displaced as well. So you can clearly understand from this. So when we say something is getting rotated about fixed point, some point of that particular object will remain fixed. Okay, whereas when we say rotation about origin, you can see that all the points would get rotated and there might be some displacement. Now why this is happening, this we need to understand. Okay, so basically in OpenGL, when we perform any rotation, it is done with respect to the origin. So what do you understand by this? It is done with respect to the origin. So origin remains fixed, all other points will get rotated. So this is what has happened in this kind of rotation. So what has happened, when we rotated with respect to origin, origin remained fixed, but everything else got rotated, right? But in this picture, what has happened is we chose the fixed point. So rather than origin being the fixed point for rotation, in this object we said something else is fixed point for rotation. So what is happening? So instead of rotation being the fixed point, we got this point as fixed and we got it rotated. Okay. So to give you an analogy, you can say if you look at your fan, it keeps rotating, but with respect to the fixed point, the fan gets rotated, but the fan still remains there, right? So something is that it remains fixed to a point and gets rotated. That is what is the meaning. So in OpenGL, as I already mentioned, the default fixed point for rotation is origin. So if we want to perform a rotation with respect to some other point, then we have to mention it in the code. So this is one of the simplest experiment among all the other programs, I believe. So we'll discuss how to write this. Okay. So first and foremost, I think all of you by now would be clear about what is moving coordinates and how do we set it. So let me just briefly tell you what it is actually. So you can imagine that you are having a coordinate system in fact. So if you had a coordinate system, so if you, for example, if you take a graph sheet or so, what will happen is, so if you have a graph sheet, say for example I take a graph sheet, I have this is x, y coordinates, right? This means my origin. So I will start marking this like -1, -2, -3, so on. So this you might have done in your physics class or in your maths class. So I'll tell my coordinate system is from -10 to 10. So I'll start marking here, right? This is my origin, -1, -2, -3, so on up to -10. And to the right I tell 1, 2, 3, 4, 5, 7, 8, 9, 10. So in the similar manner, what we have is in OpenGL, we have something called as a coordinate system, or which we call as moving coordinates. So this can be changed in fact. So our default moving coordinate is between -1 to +1. Okay, so I can give, so if I want to draw anything in OpenGL, my coordinate values should be only between -1 to +1. I can't go beyond that. Now I can change that coordinate. So to change that, we will make use of this function, that is dual ortho 2D. Now how does this work? So this is left, right, bottom and top. Okay, so what is it? These four parameters are left, right, bottom and top. So left is -100. So I am telling my coordinate system, this end point is -100 and this point is +100. So my origin is somewhere here in the middle, right? Same way, top and bottom, what I am telling, bottom is -100 and top is +100. So you can think this as y-axis runs from -100 to +100 and minus 100 to plus 100, and similarly x-axis runs from minus 100 to plus 100. So now you are free to give your coordinate values anything you draw in between minus 100 to plus 100. Otherwise, if you don't want to change the default viewing coordinates, you can keep it as it is, but do remember that all your values should be between minus 1 to plus 1, because OpenGL default coordinates between minus 1 to plus 1. Okay, so when we change the viewing coordinates, actually what is happening is any transformation what we do, that is the changes which we carry out in OpenGL, will be done in the form of matrix transformations. Okay, so we have multiple matrices. So one such matrix is called as what? Projection matrix. Okay, so when we are trying to draw any object, so we will be making a modification to a matrix called as model view matrix. But when we make a change to the coordinate system, so the viewing coordinates, we are expected to make a change to the projection matrix. So what we are supposed to do is, the default matrix mode in OpenGL will be model view. So before I make a change to the model view, to the viewing coordinates, that is before setting GL or to 2D, I will change my matrix mode from the default mode. What is default mode? I told it is model view. I will change it to projection, that is GL underscore projection. Now you know that in matrix multiplications, any matrix you load with identity matrix, you will get the original matrix itself, right? So in my GL projection matrix, what I will tell, first load your projection matrix with identity. So when I set it with identity, what happens? Whatever values I give next, that will get multiplied and will reset the values to those values. So that means when I say GL load identity, I change the matrix mode to projection. I made the matrix GL projection matrix to identity. Now I set the values minus 100, 100, minus 100, 100. So the projection matrix is loaded exactly with this value. So basically it is getting multiplied. Identity matrix with these values, the matrix projection matrix gets loaded with these values. That's what it means. So since we have already done what? Projection matrix we have changed, and I said default matrix mode is model view in OpenGL. Now I will have to come back to the model view matrix mode. So once I finish setting the viewing coordinates, we have to change the matrix mode back to model view. Now you might have a doubt, what will happen if you don't change? So sometimes you may not be able to make any difference. So why is it necessary, you might think. But when you apply the transformation, especially if you want to try like rotation, translation, or any other kind of transformations, and if you keep resizing your windows every time, so every time you resize your window, what will happen? The objects in the window will get be redrawn. That means everything will get erased and will be redrawn. So you might see some disturbance in the object. So it might get smaller, it might get larger. So some disturbance will be there. So to avoid all those things, we'll have to always follow these steps. First, before changing the coordinate system, change the matrix mode to projection, load it with identity, set the coordinate system, and change the matrix mode back to model view. Now again, here we are adding GL load identity. This may not be essential always, okay? So since we are using some kind of transformation, that is especially rotation in this program, we have to load the model view matrix as well as identity matrix. Otherwise, if you ignore this statement, so you will not find any difference, or there is no harm in your program, okay? So I hope you understood what is the meaning of this. So we are changing the coordinate system from the default mode of minus 1 plus 1 to minus 100 to plus 100. Why can't we change to something else? Is according to your wish. If somebody wants to draw your triangles in the coordinate system which lies between minus 1000 to plus 1000, you can still do it. So you can change these values from minus 1000 to 1000, or if you want to change it to 500 to 500, it's up to you. Whatever you want, you can do it, okay? It's up to you. Now we will start drawing the triangles. Since in the previous line we had given the coordinate of minus 100 to plus 100. Now if you imagine that I will give the triangle coordinates as minus 2, 2. So the triangle looks very small, right? For 100, the value 2, 3, 4 are very small. So according to this coordinates, you can set your triangle coordinates. Now how to draw the triangle? What does a triangle look? How does a triangle look like? We know triangle has what? Actually, it has 3 vertices, right? So we have 3 vertices. Let us assume the 3 vertices, and 3 vertices. Each vertex will have 2 values. Which are the 2 values? X value and Y value. So we have to give how many values altogether? 1 vertex, 2 vertex and 3 vertex values we have to give. So here we have set the vertex value as what? Minus 80 and minus 60. So the first vertexes might be minus 80, minus 60. The second vertex is what? Minus 20, minus 60. So minus 20, minus 60. Then we give minus 40 and minus 20. So minus 40 and minus 20, somewhere like this. Okay. So we got the three vertices. So this is again absolutely up to your wish. According to the author, what you have set, you can set the triangle coordinate. So I hope you understood why did I give here 3, 2. 3 because we have 3 vertices and each vertex has what? 2 coordinates. So this is x value, y value, x value, y value. So there are 2 triangles. Actually we are expected to draw a triangle like this, right? So we want 2 triangles to demonstrate rotation about origin in fixed point. So that's why 2 coordinates are being given here. One for rotation about fixed and another for rotation about origin. Okay. So these things I think you will be very clear since you are already doing all the coding part. I will not explain again. Now so I had told you that we will discuss only about what? How to perform rotation about fixed point and origin. And I also mentioned about what is it is default, by default, okay, we are going performing the rotation with respect to the origin. That means origin will get fixed, all of the things will keep rotating. So when I try to so first how to draw the code is draw the triangle. So your triangle this triangle will be drawn. So triangle is a function name. So you know how to draw the triangle. Just give GL begin, GL underscore triangle, and we have 3 vertices that you have to give. GL vertex 2F because it's 2D. Then you give the XY coordinates. So we have 3 vertices. Repeat GL vertex 2F function 3 times, each time giving first coordinate, second coordinate, third coordinate, and then give GLN. So that will draw the triangle for you. That's all you have to write in triangle function. Okay. Now, so how to perform a rotation? We are expected to perform rotation. How do we perform rotation? So it's quite easy in OpenGL. So we have a built-in function called as GL rotate F. So for this we have to mention the angle with respect to which we have to perform the rotation and the axis with respect to which we have to perform rotation. So for example here, if I want to rotate some object with respect to 45 degree, you just give instead of theta here 45, and if you want to rotate with respect to x-axis, that means keeping x constant, you want to rotate y and z. So then you can make 1, 0, 0. That means x is 1, y is 0, z is 0. Okay. If you want to rotate with respect to y, you can give the y-axis. Now in this case we are rotating with respect to z-axis. Why z-axis, why not x and y-axis? You can always check because we are drawing in 2D. It is always better to, if you can see clearly the rotation with respect to z-axis. That is why we are writing. So now what we did? We drew the original triangle. Okay. We rotated our triangle and we redraw. Okay. Now what you might get a little bit of confusion here. Okay. Now as I told you, see, when I make any transformation in OpenGL, all the transformation will be carried out in the form of matrix multiplication. Okay, so especially these transformations like rotation, scaling, translation, everything will make an impact on your model view matrix, right? So when we say a model view matrix might already have some value. Now when we perform the transformation, the model view matrix value will get affected. So what will happen now is, I have drawn a triangle. So I want to rotate this triangle with respect to some degree. So I will do what? Rotation with respect to say 45 degree, and I want to see what the original triangle as well as what I want to see is the rotated triangle. Sorry, I am not able to draw it clearly, but let me try out. Okay. So basically how many triangles I should get? The original triangle which I drawn and the rotated triangle, right? So I draw the triangle. Okay, I will give the rotation with respect to how much I have to rotate, and I will redraw the triangle. Okay, now you might have doubt here. So what I said was, I was explaining that all the transformation will be carried out in the form of matrix multiplication. So when I said GL rotate theta with these angles, these values are going to make some impact on model V matrix. So when I redraw this original triangle, what will happen? This rotative function which is loaded in the model V matrix will have an impact, and when it draws this triangle again, it will rotate the triangle and draw. That is what is happening. Now why we need this push matrix and pop matrix in between this? So if you miss out these two functions, push matrix and pop matrix, if I write any code after this rotate, everything will get rotated with respect to this angle. That means, say in this program, since we are rotating, so just drawing the triangle and rotating it, it may not make a much difference. So for example, you think you want to draw a house, and on house you wanted to draw some tilted object, so you use some rotative function. So you didn't use this push and pop matrix. After drawing the house, I wrote some code for drawing some tree, I wrote some code for drawing the sun, everything. So what will happen? All the objects will continue to draw with respect to this rotation. So I don't want this to happen. I just want to rotate only one object, that is the triangle. So when I want to have an impact of rotation only for certain objects, so make sure that you will use push and pop matrix. That means the previous contents of the matrix will be pushed to the stack. So for the new matrix, you are trying to have an effect of rotative for only this much of code, and once you perform the rotation, the previous matrix will be popped out from the stack. So to make sure that the rotation will get implied only between this push and pop matrix. So if you write any code between push and pop matrix, all the objects will have this impact of rotation. That is what is the meaning. Okay. Now when I write only so much, I didn't keep any point is fixed. That means now no coordinate is fixed here. So this is nothing but called as rotation about the origin. So origin in the coordinate system will remain fixed. Rest everything will get rotated. Okay. Now this is what this code is trying to do. Now why we need this? Actually in the program this is not expected, but if you see your output here, we are getting some text here, rotation about origin, rotation about fixed point. Though it is not expected in your program, we just thought it will look little better to show that what is the difference between these two rotations. So you can add the text. So it's very simple to add the text in OpenGL. So whatever store the text what you want to display. Suppose you want to display your name. So for example, you want to display the name. Create a character array, put a name here, and this is GL raster position 2F minus 1510. So what is the meaning? Where do you want the text to be applied? So we had our coordinate system here between minus 100 to 100. So in our window, if you see, this is my window, this is minus 100, this is plus 100, this is minus 100, this is plus 100. So I want this text just below this triangle, and we are knowing that your triangle is between minus 80, minus 60, minus 20, minus 60. So accordingly, we want the text to come just below this triangle. So we are setting the text position in minus 50, 10. So if you choose something else, you can set this position according to your wish. Okay. Now I am displaying the character one by one. From where I am displaying? From this S array. So how many characters are there? It depends on the length of the string. That's all we have to do. So this particular font which we are using is bitmap 8x13. So it is a raster text font. So you can always change this. There are many other built-in fonts, so you can try out the different fonts, whatever you want to see. Just check out and change. You will get the OpenGL manual, right? In that you can check and you can keep changing this. So this is actually not needed for your program, but if you do this, it will look very better. Okay, so I think, so remember one thing, when you want to perform a rotation with respect to origin, all you need to do is just use a rotative function. Okay, then you use push pop. Between the push and pop matrix function, call the code whichever you want to have rotation, means for which object you want to apply the rotation. That's all you need to do, because rotation is always fixed with respect to origin. That's all we have to do. Now let us come back to how to perform rotation with respect to Okay, now let us I'll just explain you the process of how we can perform rotation with respect to some fixed point, not about the origin. So I'll try to write here itself how we can make the changes. So instead of calling triangle with respect to origin, we have another triangle. So all we need to do is first draw the triangle as usual without any rotation. So I'll call fix of 0 and what? Triangle fix of 1, and what I need to do is what? Fix of 2. Okay. Now there is one important thing what we need to do. What is that important thing we need to do? That means I don't want origin to be fixed. So I don't want rotation about origin. Instead I want what? Rotation about the fixed point. So which point to be fixed? It is my wish in this triangle any one coordinate I want to keep fixed and rotate. So if I want to keep this as fixed, keep it fixed and rotate with respect to this point. Like, got it? If I want to keep this fixed, keep this point fixed, let the other two rotate, right? So these two are rotating, this is fixed. So I want this fixed, okay, keep this fixed and everything with others are rotating. So in this case, fixed to the origin, I didn't take any of these coordinates fixed, I just kept origin as fixed. So everything got rotated with respect to origin. So if your origin is here, the triangle got rotated, keeping origin as fixed. That's what has happened, okay? Now how do we do this change? So we call the fixed with respect to these coordinates. Now which point in this, suppose let us assume we want to make minus 80 minus 60 as fixed. So what I will do is I will make use of a function called as GL translate f. So I'll write GL translate f. Okay, translate f, and which point I want to fix? Minus 80 minus 60, u minus 80 minus 60, z axis is anyway 0, give 0 here. Because translate f takes 3 parameters, we have to give 3 values. Since we don't have z coordinate value, it is a 2D object here, a z value is 0. Okay, so here it's not capital, it is lowercase. Okay, now what we understand by this translate f function, there is a mistake in the spelling check. Translate f. So what's the meaning of translate? Translate is nothing but when we want to move an object from one place to another, we are making use of the translate f function. So basically when we want to perform a rotation with respect to any other fixed point other than the origin, it is like we are going to translate that point to the origin. Something like we want to instead of origin being fixed, we want that some other point to be acting as origin, something like that. Like we are going to shift the point how much units? So minus 80 minus 60. So that means you move your origin to this location, minus 80 minus 60. Perform the rotation. So same as the previous case, perform the rotation. So your matrix has set with this values, translate value, it got rotated. So once we complete this translate and rotate is done, you bring back to the original position. What is that original position? We have translated to minus 80 minus 60. Now I want to come back to the origin. How do I get a displacement? So for example, see I was standing here, okay, I moved somewhere to this point. Now I want to for performing rotation, I want to come back. How do I come back? Move back, right? You understand with this concept? I'm here, I moved here, I was here, I moved here, I moved to this place, now I want to come back. So what I did, go to that position and come back. How do I come back? So I moved in minus 80 minus 60 0, so I want to come back. How to nullify this movement? If you are moved in negative, come back. How to come back? Bring back to the same value, so you have to give positive here, right? I want to just, I have gone in negative axis, I want to come back, so you move in plus 80, so you will be in the original position. So now here what am I supposed to be doing is translate back to original position, minus 80, 60 and 0. Okay, now let us assume you wanted to perform a rotation with respect to fixed point 80, 60, 0. What will you do then? So you will translate 80, 60, 0. Perform the rotation with respect to that point. When you come back, what you have to do? Minus 80, minus 60, 0. Right? How much if you move in negative axis? Come back with positive. Like basically you had gone so much, come back to the point. Right? Now if what happens if I don't use this translative? Nothing will happen. That's it. I mean what happens is all the remaining rotation will be performed with respect to minus 80, minus 60, 0. So others also will, if you want to keep other point as fixed and perform the rotation, still it will make minus 80, minus 60, 0 as fixed. So we don't want that to happen. So this translate whatever we have written should be applicable only to this code. So so for the rest of the code we don't want to have an impact. So you shift, it's like instead of keeping origin as fixed, you move so much to the point where you want to keep fixed, perform the rotation and move back to your original position. This is what we have to do. That's all in this program we are doing and nothing else. Okay, so it's a simple program. So this concept, if you understand, this can be applied for anything. You write the code for like any kind of animations and all, you can perform basically using this code. So I've already written the program here. I'll just check out. So I enter the angle of rotation, so I'll keep 90. So this is how it is getting fixed. So here for this, rotation is with respect to origin, so origin is fixed and it got rotated. Here whatever angle I give, say if I terminate this program and then again with angle 180, see this triangle got with respect to origin, after rotation it got shifted here, but this point is fixed. So still if I want to give 360, see 360 degrees, this is getting overlapped, right? So we can't see the rotation. Let us take, say for example 87 degrees, something like that. See, you can clearly see the rotation about the fixed point. So that's all in this program. So you just have to understand how to use the rotator function and how you can perform the rotation with respect to fixed point.